Welcome everyone. In this video, we are going to learn how to add procedural bevel to any logo and a frosted glass effect like this one. You can find the link to download the finished files in the description below. On this channel, I'll be uploading videos about geometry nodes in Blender, where we focus on creating things using nothing but geometry nodes, or as I like to call it, OnlyNodes. I'll also be making VFX tutorials where I discuss the fundamental and advanced concepts and share my industry experience from working on Hollywood movie productions. If you enjoy this type of content, please consider subscribing. To begin with, let's import the logo as SVG into Blender. Go to File, Import, Import SVG, and select the SVG file that you want to import. Once the logo is imported, select the shape that you want to extrude. And this is how people normally convert a curve into a 3D geometry. Add some extrusion and depth for bevel. But the problem is, sometimes you get weird artifacts like this. And mostly it's hard to know what the problem is or how to fix it. So today we are going to learn how we can recreate this in geometry nodes so that we get more control over the process. And once we create this tool, we can apply that to any curve. Let's reset all these values to 0. And it is important to change the shape type from 2D to 3D, or else it won't work. Hide all the rest of the curves. Go to the Geometry Nodes workspace. Create a new Geometry Node modifier. Add a Fill Curve node, which fills and converts the curve into a mesh plane. Then add an Extrude node to extrude it into a geometry. Turn off Individual and reduce the offset value. Now, how do we add bevel to the edges? There is no straightforward way to add bevel in geometry nodes. We'll have to do some workaround to achieve that. So before we added the fill, add an arc curve. Then using this as a profile curve, convert the input node into a mesh. Reduce the radius and you get something like this. We want this curvature to be outside the curve. We can tweak that by changing the start and the end angle. Set the end angle to 180 degrees, then tweak the start angle until you find the right starting point. Seems like minus 90 degrees should be the start angle. Adjust the radius, and this is the same artifact we saw at the beginning. This happens because the curve's direction is not completely straightforward. There may be some irregularities. There is an easy way to fix this. Add a resample curve node, then change the mode to length. I'm going to set the length to 0.001. We can fix that later if needed. The profile arc curve is intersecting wherever there are sharp corners. We can hide this part if we fill the open space, but when you want it to be transparent logo, these would be visible. When you go to the top view and toggle between the curve and the mesh, you can see this is where the base curve is. Once you add the curve to mesh node, the geometry becomes larger than the curve. We want the logo to preserve its own shape and add only a bevel. So to fix this, what we can do is move the profile curve slightly outside. At this scale, it might be difficult to play with the transform values. Let's just transform this logo to a bigger size so that we don't have to work in such a small scale. Add a transform node, then add a value input to scale value, which applies the same value to X, Y, and Z. Increase the scale so that we get a larger scale to work with. Add a set spline resolution node to adjust the resolution of the curve if needed. Slightly increase the arc radius to compensate for the scaling. Go to the top view. Now if I toggle between the curve and mesh, you can see the curve is inside and the mesh is coming outside of it. We want this to be inside the curve. To do that, we need to translate this profile curve. try translating in different axes. This is the y-axis and this is the z-axis. So x is the axis we should be translating. But how much it should be translated? It should be the same value as the radius. Plug in the radius value separately, so you can increase the radius value here and plug in that same value into the x and then multiply that by -1. Now when I change this value, the geometry is contained inside the curve. Once we have the bevel, we need to fill the top part. The problem is the input curve is here, but we want to fill only this area. So how can we select this edge in order to fill it? We can capture it from the endpoints of the profile curve arc. So add a capture attribute node, then add an endpoint selection. These edges, which are highlighted in white, are the end and start points of the arc, but we need only one edge. If I make the endpoint 0, now only the top edge is highlighted. To fill this section, first add a delete geometry node and add the selection from the capture attribute node. It is deleting only the edge. To invert this, add a Boolean math node and set the operation to not. Now we have the edge that we can fill. But this still is a mesh and needs to be converted to a curve before we fill it. Add a mesh to curve node and change this value to n-gons. When geometry nodes in Blender fills a curve, it ignores the curve's position on the z-axis. It projects it from top view and generates a flat surface where the z position is 0. As you can see here when I toggle between the mesh and the curve. We need to translate this in the z-axis with the same value as the radius. Add a new group input. Change the name of the input to radius. Use this value to translate the mesh in the z-axis. With Node Wrangler add-on enabled, click and drag holding Ctrl plus Shift to join these two. Add a transform node here, then plug in the radius value into the Z translate. Now we have filled this section of the geometry. You can duplicate this filled curve, then multiply the Z translate by -1 to fill the opposite side and join these two to get the final geometry. If you just want to add a little bit of depth with bevel to a curve, this will seem enough. But what if you want to add more depth to the geometry? Let's do that. We are going to divide this section into two halves. Let me reduce this resample curve length value to 0.01 to get rid of these lines. Decrease the sweep angle of 180 degrees into half, which is 90 degrees. Then let's complete the bottom section of this by duplicating this top section and flipping it in Z-axis. To do that, add a transform node to the duplicated section and set the scale value of Z-axis to -1. To create a depth extrusion, fill this input curve and extrude it. Turn off individual. Set the offset value. Then add that as a group input and rename it to depth. Join it with the top and bottom sections. We don't want this top section to be filled. Delete that by adding a delete geometry node and input the top section into the selection. And change the domain to face. To offset the top section to match extrusion edge, add a transform node and translate the top section in Z-axis to the value of depth. Once everything is completed and joined, merge every mesh into one geometry by adding a merge by distance node. Smooth these edges with a set shade smooth node. If you want to add an offset to the bevel, if you want it to be slightly outside or slightly inside, then you can add that value here by adding it to the translation of the profile curve. Add this value to the group input and name it as offset. Using this value, we can offset the bevel slightly outside or more inside. But the extrusion depth is not moving with the bevel because we used the input curve to extrude it. To fix this, instead of using the input curve, we need to extract these outside edges of the bevel and extrude them. Same way how we extracted the inside edges to fill the top section. When I plug the viewer node into this selection, you can see the inside part of the curve is getting highlighted. To get the outer edges, we need to capture the other endpoint. Duplicate the endpoint selection node and add it to the capture attribute node. Then switch the endpoint. Duplicate this Boolean math node and add it here to invert the selection. Delete this selection to get the edge. Now that we have this edge, let's move this section here and input the extracted edge with the mesh to curve node. The extrusion moves along with the bevel now. Let's name this tool Solidify Bevel. We can apply this to other shapes. If you see a warning like this, that is because the curve is not set to 3D. Increase the bevel radius. If the bevel seems reversed or inversed, that means the curve direction is reversed. To fix that, add a reverse curve node and add the selection to the group input, which creates a Boolean input. Then you can toggle the curve direction from here. Make the radius and depth values identical for all the curves. Next, we are going to create the material. Set the material in the geometry node. I'm using the default material. Go to the shading tab, select the material, set the render engine to cycles. Change the default lamp's type from spotlight to sunlight. Then add an environment lighting. Select an HDRI. To get the glass effect, first set the transmission weight to 1. If you reduce the roughness, that gives us a clear glass look. Increase the roughness to add a frosted glass effect. The line that appears here is because of the face orientation. Go back to the geometry nodes and from the overlays, turn on face orientation to find any inverted face normals. This section's normals are pointing outwards since we flipped it in the Z direction. To fix this, add a flip face node here. Get back to the shading tab. Change the sunlight's direction. And add a ground plane to add some shadow and depth. The ground plane is created at a Z value of 0. The bottom part of the logo is below the plane. Translate the entire geometry by the radius value in the Z direction. Now the bottom part of the geometry is intersecting with the ground plane since they both are in the exact same position. This might create some issues, so to be safe, move the geometry away from the plane by a very small amount so that it doesn't intersect with the plane. Reduce the strength of the sunlight and add some softness to the shadows. To give it a little bit more depth, add some colors using noise texture. Reduce the scale value. With the Node Wrangler add-on enabled, press Ctrl T to add a mapping node, using which you can offset the noise texture. Scale value of 1 looks larger to me, so let's increase it to 2. And I don't want this color to be so saturated, so I added a hue saturation value node, then reduced the saturation and increased the value a little bit. To make this look more like a frosted glass, you can add coat and sheen value and play with the roughness. In the render section under color management, you can change the look to punchy to make it look realistic. Set a camera angle. Use the shortcut Ctrl Alt and numpad 0 to align the active camera to the current view. Make some final adjustment to the material and the light value. Hit F12 to render the final image. Save the rendered image as OpenEXR. You can edit the final output in any photo editing softwares like Adobe Lightroom. I'm using Darktable to do some color grading. And this is the final output. In the next video, we will see how to create a product rendering look like this and procedurally add droplets to the geometry.